Today we're going to be talking about Riemann sums and definite integrals. And remember that when we've started talking about area, so like in our last video, we were drawing in little rectangles here. And we had different ways that we were drawing in our rectangles. We were either doing a left interval or a right interval. And then we made these rectangles infinitely small so that eventually they were about the width of my little writing device so that I could get the area under the curve. So remember, I was summing up all of my heights, which were the function values, and then this delta x sub k is the width. And one way to define this is taking the limit as n goes to infinity, so the number of rectangles, n is standing for the number of rectangles of our our height times by the width. And what we're going to be doing today is we're going to be looking at this definition and trying to figure out the function and the interval that we're taking and finding the area over. And this is how we find what we call the definite integral. So our definite integral is the limit as n goes to infinity of this function is equal to this. And remember, that is read as the integral from a to b, so a is my smaller number, b is the larger number, of f of x dx, or f of x with respect to x, meaning I'm finding the area under the curve to the x-axis. That's what that x there means. It's we're finding the area to the x-axis. Okay, so remember the first thing that we really talked about was limits. And then we defined limits when we were talking about derivatives. Now we're using limits to talk about integrals. Okay, so let's break down that integral symbol for you. Okay, we have our a to b, so the lower limit, the upper limit, integral sign. We talked about that when we talked about antiderivatives. This is the integrand. Okay, and then this is called the variable of integration. Okay, and again, remember this means area under the curve from a to b. So our first example, and I have this example that is one that is very similar to something we're going to find in our textbook, and it's a little different than the limit definition. Every book kind of has their own take on this limit definition. In this limit definition, we have some c sub I, which really, that's also known as x, okay, at any point on the ith interval. Basically, these are all standing for the x variables in our function. This is the delta x, okay, and what our limit is happening here is the delta x is going to 0. This change, remember delta means change, okay, that change is going to 0. So this width is getting infinitely small, okay. So what we need to do is we need to figure out the function. Basically, what you're going to do is you're going to substitute in for c sub I wherever you see an x. So my function is 7x squared minus 4x plus 8. Okay, this is the interval. The smaller number is a, the larger number is b. So I need to write this as a definite integral. So my integral symbol from a to b, but you actually want to write in that a. My a is 2 to 5 of 7x squared minus 4x plus 8. Put that all in parentheses because that's the function I'm taking the integral of, dx. Okay, so that's how our book does it, but the AP test actually takes a little bit of a different take on this definition. Okay, so this is more similar to what you might find on the AP test. Okay, so we have here our definite integral. And then we have this written as a limit. Limit as n goes to infinity, so my number of rectangles keeps getting bigger, which makes the delta x smaller if you think about it, of a, okay, remember that's my starting point, k delta x. K is standing for whichever rectangle we're on, okay, the first rectangle, second rectangle. Remember, we kept adding a delta x. We kept adding a change in there, okay? Remember that delta x, I talked about this in a few videos ago, b minus a over n. So we just substitute in b minus a over n. So let's kind of break this down, okay? What I'm going to be giving you is I'm going to be giving you a Riemann sum, okay? And that's what they're called. This big limit definition, it's called a Riemann sum. So you first have to determine delta x by looking somewhere where you could have some number over n. And then you're going to be determining x sub k, okay? Where you're going to have your starting point. I'm making up numbers here, guys. 7 plus k, okay? So you're going to have some like x sub k. Actually, I'm not going to call it x sub k. I'm going to call it I'm going to leave it just as x times by 5 over n. So you're going to have the delta x in there. You're going to use that to determine b, because remember, delta x is b minus a over n. So if we have this as a, we're then going to be able to substitute in to get what b is. Then you're going to rewrite the sum using this symbol, x sub k, and x. And then eventually, we're going to be writing it as an integral. I think once we do a few examples, hopefully this will clarify this a little bit for you. Okay, so like I was saying, I'm going to be giving you some sort of crazy limit with the summation. Remember, this is summing up all of my different function values, okay? And kind of our goal is to be writing this as an integral. So be rewriting this as an integral of some function dx. Okay, so I need to determine delta x. I apologize, I don't have a lot of room on this screen, but I think it's important for you to see the steps. For the delta x, you want to find something that looks like it is some number over n that's not associated with a function. And that's right in here. Okay, so here I figured out my delta x is 3 over n. Okay, so now look where you would have something, determine x sub k, where you're going to have some number plus k times delta x. So some number plus k times delta x looks like it's right there. So my x sub k, it looks like it is 1 plus k times by 3 over n. This tells me that's my a. Remember, my delta x is 3 over n, which is b minus a over n. So if I substitute in a, I'm going to do it up here. So I have 3 is equal to b minus what we just figured out, a was 1. So b is going to equal 4. Okay, so now I know my a is 1, my b is 4. Their difference is 3. Their difference is 3. Okay, now rewrite the sum using x sub k and delta x. So what I mean there, and eventually, hopefully, you're going to be able to skip this middle step. After a few examples, you might see it right away. Okay, my x sub k is that blue highlighted piece. So I have x sub k to the fifth power. My delta x was that blue highlighted piece. So my delta x here was 3 over n. Okay, so now you can hopefully see that your function is something to the fifth power. This is the function. Oh, I did something wrong here. I wanted to make that delta x. Okay, so my function is x to the fifth power, so that becomes that piece, and then dx. That dx is really important, okay? If you're not writing the dx, you're going to get points taken off. Every time we have an integral, I want you guys writing that dx in there. So that's how you would do this type of problem. Now let's go the other way. Now let's write the following integral in summation notation. So I have to do the limit as n goes to infinity of a summation. So we're going to start with k equaling 1, f of x sub k delta x. So let's do some work over here to the side. Remember, delta x is b minus a over n, which is 6 minus 4. So that's 2n. Remember, x sub k is a plus k delta, I was so worried about something else, plus k delta x. So x sub k in this place, a we're starting at 4, plus k times 2 over n. So now I have the limit as n goes to infinity x sub k is this 4 plus k over 2n times by delta x, which is 2 over n. Now what's the function? Function is square root of x. So the square root of my x, so that's 4 plus 2 over n times k. I just switched those around. I wasn't liking how it was looking there. And then times by 2 over n. Okay, so that's writing stuff as going between the limits and the functions. And you're going to need to know how to do that. Okay, now remember also, this means area under the curve. This integral here, this whole thing means the area under the curve of x plus 5. So x plus 5. 1, 2, 3, 4, 5. I'm drawing in the curve here. I like to draw in, went all the way to 5. Man. Okay, so I promise that's all on there. Okay. So it's area under the curve from -3. 1, 2, 3. So -3 all the way to 5. So basically, I'm looking for this area, and it's area to the x-axis. Okay, so kind of shading in all of that area, we see that it's a trapezoid. Okay, and that's actually helpful. In the next video, you're going to need to know what the formula is for area of a trapezoid. 1/2 the height, base 1 plus base 2. Remember, the bases are the pieces that are parallel. So This distance here, that's my height. So what is that distance? That is 5, 6, 7, 8. This is base 1. This is base 2. So base 1 is 1, 2, 2 units. Base 2 is 10 units. And then simplifying all of that, we get 48. Sketch the region, use a geometric formula to evaluate the integral. Okay, I specifically made this really extreme. 487. Remember 487. Let's label my y and my x-axis. I'll put it in a different color. Okay, remember this is y equals 487. Well, that's a straight horizontal line. And I'm going from -2 to 7. Obviously, you realize it's not to scale. So I'm looking for the area of that rectangle. Well, the area of my rectangle is my height, so 487 times by my width, which is 7 minus a -2. So when I solve that, I'm going to be looking at 4,383. So therefore, when you have a constant, when I have a constant here, it's the constant times by b minus a. Height times width. And that's actually going to mean something to us after we do an activity. I have kind of a fun activity for our 4.4 lesson. Okay, sketch the region whose area is given by this definite integral. Okay, so this definite integral here. So I'm going from -4 to 4. This is a circle with a radius of 4. It's technically actually a half circle because I have that square root function that shifted up 3 units. So it's a circle centered at 0, 0 with a radius of 4, but I've shifted that up 3 units. 1, 2, 3. So I have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So what I'm looking to find, I'm looking to find this area here. So I'm looking to find that half circle area plus that area. So my half circle, 1/2 pi, r is 4 squared plus, I have a height of 3 and a width of 8. So that whole thing is 8 pi plus 24. So that's the area of this whole thing. There are some rules for definite integrals, some different properties that you need to know. That's what I was looking for. So I'd take a minute to write down, pause the video, write down these properties. Okay. You could switch A and B and make it negative, kind of like I think about it as you're going backwards. Area from A to A is 0. You haven't gone anywhere. You can pull out a constant in front. Same thing if it was a -1. I've already talked about this one. Okay. You can add, if you're going from A to B, you could take the integral of each term individually. And then lastly, here, if you're going from A to B and then B to C, that equals the area from A to C. Okay, and I always like to kind of order these in the correct. A is the smallest and C is the largest. Okay, and this is going to be an important property for us to realize. Okay, so our first example here. Suppose that I know the area from -1 to 1 of f of x dx is 5, 1 to 4 of f of x dx is -2, and -1 to 1 of h of x dx is 7. So I need to find -1 to 1 of 3h of x plus 2f of x. So that's 3 from -1 to 1 of h of x dx. Notice I keep writing that dx. Okay, this is equal to 7, so I have 3 times 7 plus 2 times by 5, and I get a 31 here. For b, we know that this equals the negative integral from -1 to 1 of h of x dx. So that equals -7. Now for c, I'm going from -1 to 4. Well, I know that -1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx is going to equal the area from -1 to 4 of f of x dx. So that equals 5 minus 2. So this area from -1 to 4 of f of x dx is going to equal 3. And lastly, we're going from 4 to 4. You haven't gone anywhere. So that's why that area is 0. Okay, that is all I have for you guys for today. Please make sure that you do what you need to do to get ready for class. Thank you for watching.